Balancing redox reactions. Often redox reactions are difficult to look at and balance because there's a lot of things going on in redox reactions. So we're going to use what's called a half reaction method to balance redox reactions. So let's go through the steps in how to balance redox reactions using this method, and then we'll go back and do an actual example. So step one, we're going to write separate equations for the oxidation and the reduction half reactions. Then, for each half reaction, we're going to balance all of the elements except for hydrogen and oxygen first. And this is a step that you don't always have to use, so oftentimes it's forgotten. But you need to kind of keep it in your head as a step that you need to think about first. The next step is going to be to balance all of the oxygens on both sides of our half reactions. And the way we're going to do that is by adding water molecules in. We need to add one water molecule for every oxygen that needs to be balanced. And the reason we can do that is because these are aqueous reactions, so there are water molecules available for the reaction. Then we're going to balance the hydrogens. And the way we're going to balance the hydrogens is by adding hydrogen ions on the reactant or the product side. And the reason we can do that is because most redox reactions are in acidic solutions, and we know that acids have hydrogen ions in them. Now we will look later at redox reactions that are balanced in basic solutions, but we're going to follow the same general rule and just add one step to the end. What we do next is we balance charge. And the way we balance charge is by adding electrons. And we know that electrons are negatively charged, so we're going to add them to the side that we need to decrease the charge on. Once those things are done, the next thing we're going to do is look at the two balanced half reactions. And we're specifically going to look at the number of electrons that are gained in the reduction and lost in the oxidation. Those two numbers have to be the same. If they're not, we're going to have to multiply one or both of the half reactions by some integer to equalize the number of electrons that are transferred between the two half reactions. We have to have the number of electrons gained equal to the number of electrons lost in a redox reaction. The next step is we're going to take those two balanced redox reactions and we're going to add them back together. And when we do that, we want to write a net reaction, which means if we find things on the reactant side and also on the product side, we want to write a net number of those particular species. So we'll cancel out identical species. And then our last step is we're always going to check to make sure that our redox reaction is balanced. But this time it needs to be balanced with respect to atoms on both sides of the reaction as well as charge on both sides of the reaction. Before, we didn't need to deal with is the charge balanced because it wasn't a redox reaction we were looking at. So let's look at an example. Let's say that we've got this particular reaction and we want to balance it in an acidic solution. Well, the first thing we're going to do is assign oxidation numbers. So we know hydrogen's going to be a +1. We know oxygen's going to be a -2. We know iodide will be a -1. On the product side, it's a free element, so it will be 0. And we know oxygen is a -2. Nitrogen is one we're going to have to figure out because it has varying oxidation numbers. So -2 times 2 gives us a -4. +1 gives us a -3. So nitrogen's going to have to be assigned an oxidation number of +3 in order to make the sum 0. On the product side, we've got a -2, so in order to make it add up to 0, nitrogen's going to have to be +2. And when we look at this particular reaction, our nitrogen is changing and our oxygen is changing. Nitrogen is going from a +3 to a +2. That's our reduction. it must be gaining electrons in order to reduce that oxidation number. Iodide is going from a -1 to a 0. That means it's being oxidized, or it's losing electrons. So we know that nitrogen here we're going to have as our oxidizing agent, which I'm just going to write as OA for oxidizing agent. And our iodide is going to be our reducing agent. So now let's balance this equation. Our first step, we're going to write our two half reactions. So we'll look at our reduction first. And we're going to leave ourselves some space. We've got HNO2 going to NO. And our oxidation, we're going from I- to I2. All right, so let's balance out our reduction half reaction first. And we're just going to go right through the steps. Nitrogen's already balanced. We've got 2 oxygens here, but only 1 oxygen here, so we're going to add water molecules in order to balance out our oxygens. If we add 1 water molecule, we'll have 2 oxygens here and 2 oxygens here. Now we're going to balance hydrogens. We've got 2 hydrogens here. There's 1 hydrogen here, so we're going to add a hydrogen ion since it's an acidic solution. And our last step, we're going to balance charge. There's no charge on the product side, but there's a +1 charge on the reactant side, so we're going to add an electron in. And we know that reduction is the gaining of electrons, so that makes sense. Now let's balance our oxidation half reaction. Our first step tells us to balance everything but oxygen and hydrogen. We've got 2 iodines, so we need 2 iodines. Now this particular step doesn't have oxygen, so we don't have to worry about that. It doesn't have hydrogen, so we don't have to worry about that, but we do have to balance charge. We've got a -2 on this side, we've got a 0 on this side, so we need to add 2 electrons to balance our charge. Now, when we look at electrons gained and electrons lost, they're not equal in this particular reaction. So we're going to have to multiply our reduction half reaction by 2. Everything in that half reaction needs to be multiplied by 2. So this is going to become a 2, a 2, a 2, a 2, and a 2. Now we're going to add everything together. And what we're going to notice is that our electrons gained equal our electrons lost, which is what we wanted. So we're going to end up with 2 hydrogen ions plus 2 nitrous acid plus 2 iodides are going to give us 2 nitrogen monoxide plus 2 water plus iodine. And we can double check and make sure that this is balanced. We've got 2 plus 2, 4 hydrogens, 2 nitrogens, 2 nitrogens, 4 oxygens, 2 plus 2, 4 oxygens, 2 iodines, 2 iodines. Atoms are balanced. For charge, we have a +2, a 0, and a -2, so that gives us a 0 on the reactant side, and we've got a 0 on the product side. So we have a balanced reaction. Let's look at another example. Again, our first step is going to be to assign oxidation numbers. So -2, -2, -2, -2. We know that. Now we'll figure out the ones that have multiple oxidation states. -2 times 4 gives us a -8. We want to end up with -1, so manganese must have a +7. -2 times 2 gives us a -4. We want to end up with a -1, so nitrogen must be a -3. -2 times 2 gives us a -4, so manganese must be a +4. Minus 2 times 3 gives us a minus 6. We want to end up with a minus 1, so nitrogen is a plus 5. It's a redox reaction because our manganese is changing and our nitrogen is changing. Manganese is having its oxidation state go down, so that's our reduction. Nitrogen has its oxidation state going up, so that's our oxidation. So this is our oxidizing agent, and this is our reducing agent. So now we're going to balance. We're going to write our reduction half reaction and our oxidation half reaction. So we're going to have permanganate to manganese dioxide and nitrite to nitrate. All right, so manganese is balanced, 4 oxygens, 2 oxygens. So we have to add 2 waters. 4 hydrogens, so we have to add 4 hydrogen ions. And then for charge, we've got no charge on the product side, but we've got a plus 3 on the reactant side, so we have to add 3 electrons. Now let's look at our oxidation. Nitrogen is balanced, 3 oxygens, 2 oxygens, so we're going to add a water. 2 hydrogens, no hydrogens, so we're going to add 2 hydrogen ions. And then for charge, we've got a minus 1 on this side, and we've got a plus 1 on this side. So we're going to have to add 2 electrons. 3 electrons gained, 2 electrons lost, that's not equal. So we're going to multiply our reduction half reaction by 2 and our oxidation half reaction by 3. That'll give us 6, 8, 2, 2, 4, and 3, 3, 3, 6, 6. Electrons gained equal electrons lost. Now this one's a little trickier because when we look at the reaction, we've got hydrogen on the reactant side and on the product side. The net is 2 on the reactant side. And when we look at water, we've got 3 on the reactant side and 4 on the product side. So our net is 1 on the product side. And then nothing else is found on both sides, so we can continue to write what we have. So we've got 2 permanganate plus 3 nitrite plus 2 hydrogens. Water plus 2 manganese dioxide plus 3 nitrates. 2 manganese, 2 manganese. We've got 8 plus 6, 14 oxygens. 1 plus 4 plus 9, 14 oxygens. 3 nitrogens, 3 nitrogens. 2 hydrogens, 2 hydrogens. So we have a balanced equation.